The equation we're using here is Q equals mCp delta T. So M equals the mass, C sub P equals the specific heat. Sometimes you'll see this as lowercase c, which is fine. Delta T is change in temperature. The delta means change. So when we do change in temperature, that's temperature final minus temperature initial. And then Q is heat. That was a really bad Q. Okay, so Q is heat. So in most of these, you're going to be asked to find energy. Every once in a while, you'll be asked to find like a final temperature or an initial temperature, in which case you would just be rearranging this equation. But the specific heat is inherent of whatever molecule you're using, so that will never change. And typically you're given the mass. I guess I could not give you the mass and ask for it, but usually you're given the mass. When you're doing these problems, you're typically looking for either the heat or a temperature. And then heat is energy, just as a reminder. And we measure energy in joules, which is good because you can see here where we have all of our constants, joules are in all of those places. Okay, so you guys have a bunch on your worksheet. I edited the worksheet so you can only see 1 and 5. So I'm going to do 1, and then I'm going to do 5, and then I'll let you guys get to work on your own. So first thing you should always do is draw what are these called? A graph. Draw a graph. This represents temperature in degrees Celsius, and this represents energy. Sometimes you might see the bottom here like progress instead of energy, which is fine, like progress of a reaction basically, but basically energy is increasing like this, temperature is increasing like that, and we're just going to do a basic graph. So it says that my ice cube starts at 0 degrees Celsius, so I'm going to put a little dot there, we'll call that 0, and let's see, with a mass of blah 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 added to a refreshing iced tea, your heat will be absorbed. How much heat will be absorbed to completely melt the ice? So I'm here and I'm melting the ice. When you're melting, I never had a change in temperature, right? It never said I went any higher, so I'm staying at 0 degrees the whole time. Basically, when you have these, like a full one from like a negative to a positive, you have different phases. I think you guys saw this already. So this is my solid phase, this is my liquid phase, and this is my gas phase, and then here are my changes. So this is boiling or condensing, right, my change from liquid to gas, and then this is melting or freezing, my change from solid to liquid, depending on which way you're going, right? Melting is one way, freezing is the other, and then for this one, you're either boiling or condensing, right? Gas to liquid or liquid to gas. So when I'm on this flat part here in number 1, I'm melting, right? Which means I'm putting energy in. So what I'm going to do is I need to figure out which of these constants I'm going to use. So this, where it says solid over here in this like one that I did specifically, you have the specific heat of ice. Do you see that specific heat of ice? That's your solid. And then I have the specific heat of water vapor. So that's my gas. So specific heat, whoopsie, not S, C, of vapor. And then where I'm going from fusion is going from solid to liquid. So this is my molar heat of fusion. And then vaporization is here. So this is my molar heat of vaporization. So this is the part that I'm completing over here. So I'm going to use my molar heat of fusion here. So the temperature actually didn't change. So here's an example where I'm not using this equation. You use this equation when your temperature is changing. So your temperature changes here, solid, liquid, and gas. If you're not there, if you're in one of these flat spots, then you're using conversions, and you're using either molar heat of fusion or molar heat of vaporization, all of which are constants. If we changed it other than water, I would give you those constants. You'll have them. So I was given 75.86 grams of ice, so of water. Maybe I could just write H2O. Okay, and I need to, it asks me for how much heat, right? So I'm looking for energy. So I'm going to use this here as a conversion factor. Well, notice it's not kilojoules per gram, it's kilojoules per mole. So the first thing I need to do is convert my water from grams to moles. So for every 1 mole, I have 18.02 grams of water. And now I can use my conversion there. So 6.009, that looks like a colon now. 6.0, there we go, kilojoules per 1 mole. When I put all of that into my calculator, I get 25.296, but I need 4 sig figs, so 25.30 kilojoules. Did it say anything about the units? No, it just said how much heat. So I'm going to leave it in kilojoules since that makes the most sense. Whoops. There we go. So there's my answer, right? How much heat will be absorbed. So again, heat is measured in energy. Energy is measured in kilojoules. So that's our answer. So every time you have a flat part of that graph, you're going to use, again, a conversion. And every time you're going up or down, you are going to use the specific heat with the Q equals MCAT equation. It helps to draw this graph. If you're just reading the question and trying to figure it out that way, you might find yourself struggling. If you can draw the graph first, it will help you determine when you use what. So I'm going to go ahead and do number 5. So again, I'm going to start with a graph, and it says how much heat is, and so I'm just going to real quick label these: temperature, energy. Okay, so how much heat is required to convert 25 grams of ice at 4 degrees Celsius, so negative 4 degrees Celsius, that's where I'm starting. And it says to a vapor. I'm going all the way up to 110. Well, I know that when I hit 0, I'm going to have a plateau. That's where I'm going to have my melting. And I know water boils at 100, so I'm going to rise again till I get to 100. And that's when I'm going to boil. And then I'm going to rise again. So here I'm at my solid phase, liquid phase, gas phase. And again, here's my flat parts are melting and boiling. And then my very top temperature is 110, right? That's as far as I made it, to 110. So that's why I said it would be, it's helpful to draw it out. If you just read that, you might think you were doing 1 Q equals MCAT, changing from -4 to 110. That's not actually what's happening. You have 5 different equations you have to use, and then to get the total energy, you'll add each energy chunk together. So I'm going to actually number these 1, 2, 3, 4, 5, and then I'm going to go ahead and do the 5 equations over here. So I'm starting with solid, and remember going up and down is Q equals MCAT. So I'm looking for Q. I don't know what it is. My mass is 25 grams. My specific heat for solid is this number here, so 2.06, 2.06, and then joules over grams times degrees Celsius are on the bottom. And then we're going to multiply that by the change. So remember, change in temperature is final minus initial. So in this case, my final temperature was 0, because that's where my S here ended, was at 0. And then my initial temperature, again, minus initial, so my initial was 4.0. So really, my change in temperature was 4.0 degrees Celsius. So here I have grams and grams that cancel, Celsius and Celsius that cancel. If I just multiply straight across, I will get my heat in joules. All right, so my answer is 206. When I multiply all those together, did I put that into the calculator right? Yeah, okay. My answer is 206. I had, let's see, 2 sig figs and 3 sig figs, so my answer should be in 2, so that's really 200, but I need 2 sig figs. So I'm going to put it in scientific notation. Actually, you know what I'm going to do? So that's 200. Again, I need, well, actually, let me start with 206. That's 206 joules, but remember, I'm going to have to add them all together. And as I can see from here, I'm going to get answers in kilojoules when I do my heat of fusion and heat of vaporization, and then I'm going to get answers in joules when I do my Q equals MCAT. So you're going to have to convert them all one way or another. So I'm going to have to convert this to kilojoules. So 1,000 joules times 1 kilojoule equals 0.206. So with 2 sig figs, that's 0.21. And again, that was kilojoules. So there's my energy for just this first part. I'm going to do equation number 2. Equation number 2 is the flat part. So that means I'm using molar heat of molar heat of fusion, because this is melting and freezing, which is the fusion number. So I'm just taking my mass here, so 25.0 grams of water. I need to first convert my grams to moles, so 18.02 grams of water to 1 mole, and then I'm going to multiply by my molar heat of fusion, which was the 6.009 kilojoules to 1 mole, and that equals 8.33657. I need 3 sig figs, so that's 8.34 kilojoules. So that's the energy from my second equation. I'm going to move over here and do my third one. So third is Q equals MCAT, because I'm going up. So I'm calculating Q. The mass is 25 grams. The specific heat for a liquid now for water is 4.182 joules over grams times degrees Celsius. That's not at the top here, but I just know it. The specific heat of liquid water is something we use so much that honestly you're probably going to know it by the end as well. But you could Google it, or you could look it up in the reference section of your book. It's everywhere. So there it is. And then we're doing a temperature change again. This time my temperature is going from 0 to 100. So if I take my final, which is 100, minus my initial, which is 0, I get 100. And that's degrees Celsius. So I'm going to multiply all of that through, and that gives me 10,455 joules. Whoops, not kilojoules, but I do need to convert to kilojoules. So 1,000 joules to 1 kilojoule is 10, and I need 3 sig figs, so 10.6 kilojoules. So that's my third one. Now moving on to my fourth one. The fourth one is again a conversion because I'm flat. So I'm going to take my 25.0 grams. I need to convert it to moles, so 18.02 grams to 1 mole. And then I need to convert using, this time because I'm up here at boiling, I'm going to use molar heat of vaporization. So vaporization is this number here, so 40.79. So 40.79 kilojoules to 1 mole. So when I put that in the calculator, I get 56 point, how many sig figs do I need? 3. So 56.6 kilojoules. And I still have this last equation here, my gas one. So equation number 5, again, it's changing in temperature, so I'm using Q equals MCAT. So the mass, again, is 25 grams. The specific heat for the gas, the water vapor, is 1.87. 1.87 joules over grams times degrees Celsius. And then my change in temperature for that last part is 110 minus 100, so that's 10 degrees Celsius. That one actually was given to us, so it was measured to the 10th place, which that still is, so that's okay. Oops, I meant to put a C there. Okay, so multiplying all that through gives us 467.5 joules, but we need to convert that to kilojoules. So that's 0.468, right? Because I need 2 sig figs. Oh, wait a second. I have different sig figs on this one. So the reason the sig figs are different on this one, just in case you're confused, is because that 110 was actually a number we were given, right? So when we did the subtraction, the 100 we came up with, and so since the 110, the last significant place was the tens place, we needed our answer to be in the tens place, and then when we multiply across, we actually only have 1 sig fig there. So when my answer comes out to 0.4675 and we need 1 sig fig, that's actually 0.5 kilojoules. So now I'm going to take all of those answers and add them together. So my answer from number 1 was 0.21 kilojoules. My answer from number 2 was 8.34 kilojoules. My answer from 3 was 10.6 kilojoules. My answer from number 4 was 56.6 kilojoules, and then my answer from 5 was 0.5 kilojoules. So I'm going to take all of those and add them together, and I get, let's see, I get 76.25, but my last significant place is that 2. So my answer will be 76.3 kilojoules. That's how much energy it took us to go all the way from -4 degrees to 110. All of those 5 steps added together. So that would be your final answer for number 5. You will have some super short ones like this. You might have some 2-step ones where you're just doing like one of these and one of these, like a 2-step one. So you'll have all different sizes. Again, graphing it will go a long way. Please graph first if you're struggling. For sure, graph first. Okay, that's it. Please let me know if you have any other questions.